Guys, and welcome to today's class, Ace Math with Joy. So in today's class, we're going to be looking at permutation and combination. It's not going to be a one-off thing, it will run in series. Now, this topic is actually a deep and vast one. So in today's class, what are we going to be focusing on? We're going to be focusing on the concept of factorial, what's the meaning of permutation, how do we permute objects or letters, then how do we permute or permutate indistinguishable objects. So by the end of this video, I believe that if you see any question under permutation that has to do with these objectives, you should be able to confidently attack them. So please, if you are yet to subscribe to our channel or follow us up for notification on our videos, please do so. Also like and comment. Let's know if you have a question or there's something you need us to handle or whatever. All right. Okay, so let's move. You should have your pen and paper anyway. It's a math class. So first of all, what is factorial? Now, factorial is actually something used in permutation, in combination, even probability. If you are a senior student who is probably struggling with complex questions on probability, you need to understand permutation and combination well. All right, good. Now, you also use this factorial in binomial expansion. So what is this factorial? Now, this factorial of a number n, if I have n factorial, it means multiplying the number by all positive integers less than it down to 1. All the positive integers less than this n, keep multiplying down until you get to 1. Note, positive. Where are you supposed to stop at? 1. All right? So now, if I have n factorial, what are numbers less than n? N as the n minus 1 times 3, which is the n minus 2, times 2 times 1. We stop there. All right? So now, 1 factorial is what? Is 1. Why? There is no other positive number less than 1. Now, a special case of this factorial is 0. Is it possible to have 0 factorial? Yes, it is. You will see that while we solve, as we progress, you will see it. So 0 factorial is a special case, and that is 1. Is a special case. Is simply the arrangement of R out of n objects with attention given to order of arrangement. Now, to go straight to the point, permutation is simply how do you arrange numbers or objects taking order into consideration. Now, let's pause the grammar at that level. Most of you use phones. Most of you have bank accounts. Have you ever wondered how MTN creates phone numbers to serve millions of customers without 2 users having the same number? Have you also wondered how commercial banks in Nigeria generate account numbers for each users without 2 customers sharing the same bank account number? And so on and so forth. The BVN we all have, no 2 persons have the same BVN, no 2 persons have the same NIN, and so on and so forth. So this is actually generated using permutation. Like I said, let's pause the definition, we'll get back to that. So now imagine this, how powerful these digits are, the 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So now MTN, when they started originally, it was 080. Then the remaining 8 digits, which is your peculiar number, were generated using digits 0 to 9. Some digits were repeated, some were not repeated, though they have a special app created for MTN used in generating these numbers. That is permutation. And that is why you will see somebody's phone number becoming 2331755. Is it complete? 1 2 3 4 5 6 7 8. It's complete now. Now this same digits, another customer using MTN line will have 2331755. Now what happened here? Now you will see that the last two digits were swapped, right? Good. So these two phone numbers are not the same. Though they have the same exact same digits, but order has now changed the whole thing. In the first phone number, this was the 10th digit and this was the 11th digit. Coming to the second number, the 11th digit in the first became the 10th. Have you seen positioning? Right? Now that is order. Right? Now, in the case where I have man, this is first, this is second, this is third. And then another person comes to say, what of ma'am? Automatically, this is first, this remains second, this is now third. Have you seen it now? So do we now understand the grammar we are talking about under what permutation is? So the same objects, but how we arrange them, just like during assembly, you are standing in a line and maybe a teacher comes and says, you are taller, move to the back. You are shorter or whatever, please come forward. Now that rearrangement has changed the line completely. The same persons, but the rearrangement, that is order, has changed, and that is permutation. So permutation is saying that MAN is not the same thing as NAM. Now the first phone number is not the same thing as the second phone number. So you need to understand. So if you understand the meaning of permutation, it will help you to understand the meaning of combination. Now this permutation is giving us N permutation R. Now what is R doing there? What is R doing there? Now I have the word mango and I want to form 3 digits from this word mango. Now this mango, I have 5 digits, right? This is my N. Now I want to form 3 digits. I want to form 3 letters rather, not digits. This should be letter. I want to form 3 letters from the word mango. That 3 letters is my R. Do you get it now? The 3 letters can be MAN, it can be MNA, it can be NGO, and so on and so forth. So in how many ways can I arrange 3 letters from the word mango? The mango is my N that has 5 letters. The 3 letters I am to arrange from it is my R. So how can I do that? And that is, that N permutation R is N factorial over N minus R factorial. Thank God we started with what factorial is. So nobody will ask, but what is factorial? All right. So now moving forward to the third objective, how do we permutate objects? Help me and tell me, how do I do it? Do I do it first come, first serve? What if the person here cannot stand for too long and then the person here feels victimized? Do you see it? So in how many ways can this be arranged? You know, one person can come and say, okay, pick the first 3. Another person will come and say, no, pick the 3 oldest and all that. Okay? So whichever way, how best, sorry, not how best, in how many ways can this arrangement be done? The fact is that 8 of them cannot sit on this seat, right? So either I take 1, 2, 3, or 1, 2, 3, or just like that. And that is 8 permutation what? 3. Did you see that? Which is 8 factorial over 8 minus 3 factorial. which is 8 factorial over 5 factorial, right? So now you see this permutation helps us to avoid, imagine doing this manually. How do you differentiate the persons, and what if you make mistakes in the calculation, given that it is not that small? If it were to be maybe picking 3 persons from 4 persons or 2 persons from 4 persons, it will be easy to do manually. So you have your 8 factorial over 5 factorial to be equal to 8 times 7 times 6 times 5 factorial all over 5 factorial. So these two will cancel out. So 8 times 7 is 56 already from what we did in the first one. 56 times 6, and that will give us 336 ways. So imagine if this were to be an exam, a theory question. They said how many ways, just like you say how find the volume, and then you put your cm cube or your meter cube as your unit. In permutation and combination, if the question says how many ways, your unit is ways. 336 ways. Please take note in case of theory questions in WAEC and NECO. All right, next question before we move to indistinguishable objects. Positions. So how can we arrange them, given that they are all fit and capable to do the job? That is simply 5 permutation 3. Now, from the first example, I hope you understand why it is 5 permutation 3. So, which is 5 factorial. These are actually objective questions from further mathematics WAEC. So that will be 5 factorial over 2 factorial, which is 5 times 4 times 3 times 2 factorial all over 2 factorial. So 5 times 4 will give us 20, and 20 times 3 will give us 60 ways. See, I'm being careful to make sure I add my unit, so also be careful with yours. So next on our list is, what if we have indistinguishable objects? Now, in picking my 3 letters, if I can have this, I can have this, right? I can even have this. But then this part, how will you know if it is the first one or the second one? Are you seeing the confusion? That is what we mean by indistinguishable objects. So in this case, we consider how the 2 F's can be arranged. All right. Now, this staff can actually be, what if I rewrite it in this way? So now how do you know which F is F? Have you seen? So you see that these 2 F's can be arranged in what? 2 factorial ways. Why 2 factorial ways? Because there are 2 letters that are the same, right? So we have 5 digits. So that becomes 5 factorial over 2 factorial. Why the 2 factorial? Because of the 2 F's. All right? So if there were 3 letters that are the same, it will become 3 factorial. Okay? So let's look at an example. 6, 7, 8, 9, 10. We have 10 digits in the word statistics, right? So normally it should be, if you were asked how many ways statistics can be arranged, it would have been 10 factorial. But because there are digits that are repeated, we check the digits. Now S occurred 3 times, T occurred 3 times, and I occurred 2 times. I believe I captured them well. So these 3 letters occurred more than once. So we will have 10 factorial over 3 factorial, 3 factorial, 2 factorial. And I think I've told you why, right? So this S can be arranged in 3 factorial ways. You don't just call it 3. It's 3 factorial ways. Because if this is S1, S2, S3, that means we have S1. Let me use S as an for clarification or further explanation purposes. So this can be arranged as are you seeing? So there are different, not just 3 ways. You see the arrangement? It can also be S1, S3, S2. It can also be just like that. So that's 3 factorial ways, which is 6. There are 6 ways of arranging it and not 3 ways. All right. So I believe with this explanation, you can solve questions involving both the distinguishable and indistinguishable objects. So I will leave you with one question. Try it out and let's see your answer in the comment section. Please do well to follow us in our next video as we continue with permutation that has to do with that's cyclic permutation, and then permutation of digits and a whole lot of them, and then combination. So please see you in the next video. Do well to like, comment, share, and invite your friends. Bye.